Hello, I think we can start now. Welcome everyone to the State of Presto webinar. I'm Piotr Findeisen, a Presto maintainer and the co-founder of Starburst, the Presto company. With me today there are Presto creators, Martin Traverso, Dane Sandstrom, and David Phillips. We plan to have a whole day Presto Summit in San Francisco today, but as we cannot join you in person, we are doing a series of webinars to share Presto-related talks and stories from our vibrant Presto community. Martin, Dane, and David will talk about the state of Presto and the project roadmap. Prior to this, and for the benefit of those who are new to Presto, we'll do a quick overview of what Presto is and what's not. Then we will talk about the project momentum and the fantastic community growth that we are seeing. We'll cover the technical progress as well as the project roadmap. At the end, there will be a Q&A session. You can ask questions using the question box throughout the whole presentation. This is the question box. So what is Presto? Presto is not a database. It does not store data. Presto is highly performant and highly scalable SQL execution engine. It's proven at scale and for big queries and for concurrent use cases. The project was started in 2012, and since thereafter, it's a community-driven open source project benefiting from contributions from companies all over the world. Presto architecture provides separation of compute and storage, where data sources are pluggable. This architecture is a foundation for scalability and cost-effectiveness when running Presto. Last but not least, Presto lets you be free from vendor lock-in and provides optionality. By using open source file formats in your data lake, you can choose the right tool for the right job, for every job. Presto has been adopted by thousands of companies around the globe, from the largest giants through Fortune 500 companies to smaller enterprises. You will hear from some of these companies talking during upcoming webinars, and the next one is planned at the end of June, so stay tuned. So why would you want to use Presto? Presto allows you to query data, any data, and multiple data sources at once without expensive data preparation or ETL jobs, moving data from one source to the other. Highly tuned MPP, massively parallel processing execution engine, and compute storage separation yield to low total cost of ownership. Presto lets you leverage your datasets whenever they are, letting, for example, BI users derive useful insights from them using just SQL. So no matter what problem you're facing today, whether this is expensive ETL jobs, slow or impossible BI reporting, or data science challenges, Presto is a perfect fit to help you in every of these cases. Now that we have some good understanding what Presto is, let me hand over to Martin, who will talk about how the project is doing. Thank you.
Thank you. Hi, thank you, Piotr. Thanks everyone for joining. So we're going to talk about some of the changes that happened over the last year and a half. Basically since early 2019, talk a bit about the community, the state of the community, and then finish up with a discussion about upcoming changes in the next few months. We're going to go over some of the more recent changes to give you a sense of what went in the last few releases. Right. So this has been a pretty good year, year and a half for the project. Like if we look back at early 2019, we started the project with about 700 or 800 people involved in the Slack channel. This is basically a place where everyone interacts. Everyone has questions about the project. Everyone that needs help. Everyone that is trying to contribute something or develop something. They all join that Slack channel and interact there. So we started with 700 to 800 people, and by now we have more than 2,000 people registered. And that also went up from about 150 people interacting every week to 350, and we've seen a peak of about 550 people in a single week at some point. So it's a pretty active, vibrant community. it's if you compare with other communities, it's probably one of the most active ones in terms of people engaging and interacting on a daily basis. And looking at the project since the inception, we've seen contributions from more than 370 people total. This again, a lot of people come and go. Some people contribute only a few small changes, which is good. It's always appreciated. There's other people that get more involved over time, and that the number of regular contributors has been increasing too, which is really good for the project. So in terms of activity, if we look at the number of changes that went in, there's just in the last year and a half alone, more than 4,200 commits. And that's about 2,500 pull requests that we processed and closed. And if you look at the total number of change, or the amount of code and how many lines of code had changed, that accounts for more than 20% of the entire code base, which is pretty significant. And also to give you a rough sense, the project has been around for almost 8 years now, and the changes in the last year and a half are more than 20% of all the changes in terms of number of commits since inception. So let's talk a bit about some of the most important changes that happened over the last year and especially the last few months. And we're going to talk about 4 areas: language features, performance, changes to the query engine, and improvements to security. And this is by no means comprehensive. There's a lot of other changes that are not in this slide, and I encourage you to go look at. We have a blog post talking about all the changes that went in 2019. I encourage you to go look at it. We have a link to the website and the blog site later in the presentation. So looking at language features, there's a couple of notable ones, and these are basically things that help improve the usability of the language, of the tool. So now it's possible to add and see table comments and column comments. So you can, using SQL commands via Presto, you can modify the comments, you can add them. This can, of course, this can help people are interacting with Presto and trying to understand the structure of tables. They can see that information and make better sense. Previously, they had to use external tools for that, for modifying those comments and setting the comments. Similarly, now it's possible to create and define schemas directly from Presto instead of having to go around Presto and doing it on the backend connectors. Like, for example, if you were using Hive previously, if you wanted to create a schema, you would need to do it using Hive tools, and then from Presto you will be able to create tables and query the tables and so on. Now it's possible to do that all within Presto. We made a number of improvements to some of the more esoteric features of the language. So we support lateral, construct, and nest. We made improvements to be able to use those in the case of outer joins. We added support for the fetch first and offset clauses, which are in the SQL standard. So that brings the language a bit closer to supporting more features from the SQL language. And then there are a number of other improvements that happened in the way Presto deals with some constructs, like selecting all fields from a row column and so on. We're not going to go into details, but just know there are a number of other improvements to usability. On the query engine, we made also a number of improvements to the core execution engine that, at the end of the day, they all help with performance in one way or another. For example, there's dynamic filtering, which is a feature we've been working on for a few months. I mean, people from the community, of course, have been working on it. And this is a feature that allows Presto to short circuit the execution of queries that have joins by taking advantage of the data that dynamically shows up in one side of the join to stop processing data early from the other side of the join. This, when combined with formats like org or Parquet that have internal stats, that Presto can use to filter them out early before decoding them can help improve performance of queries. The next big change that happened is late materialization. And when we say that late materialization, we're talking about a feature where Presto can delay reading and decoding certain data parts of the data only to when it needs to access that data. For example, let's say you're doing a scan followed by some filtering, and then you're doing some computation on top of that data. The rows that don't match don't need to be decoded for doing that computation. So late materialization allows the engine to skip decoding those rows. And this is something that Presto has already supported for a long time for the bottom layer of the query, like a table scan followed by a filter by a project. We've extended that to support other operations like joins, the broadcast joins, and top end, semi joins, and so on. And we're going to be doing more work over time to support this for other operators in the engine. There's been ongoing work on making it possible for the engine to communicate more complex operations to connectors. This means, historically, Presto could tell a connector that a query was going to scan a table. It was going to filter by a certain criteria. The criteria was pretty simple. It was arrange queries over values in the columns, and that was about it. So we've been working on being able to express more complex actions that need to happen to the connector, so the connector can, in the case of more sophisticated systems like databases, it can formulate queries and send them to the data source such that those operations happen on the backend side. So, for example, if you have more complex expressions like aggregations or limits or even joins, if the underlying data source understands and knows how to do them, we want the data source to do them inside, so that less data gets transferred to Presto and Presto has to do less work. Now we've done this feature takes multiple parts. We've added support for limit, for table sample. We improved projection pushdown. We improved filtering pushdown, but we're still working on adding support for other operations. We're going to talk about that in a bit. And then finally, there are a number of improvements to the cost-based optimizer, notably the ability for the optimizer to consider peak memory usage when it makes decisions about join, reordering, and type selection. And at the end of the day, that can improve performance for certain kinds of queries. So, and then in terms of, so that was talking about the query engine, the architecture of the query engine, and it's about making the engine smarter, be able to process things smarter. We also make Presto be able to process things faster. So one example of that is we improve the operator, the unnest operator. So when we have highly nested data with arrays, Presto can, and you use the unnest construct in SQL, that part of the query can now run up to 10 times faster. We've seen cases where it goes from 2 times to 10 times faster, maybe even 20 times faster, depending on the shape of the data. Again, this is something that can help if you're using, if you have highly nested data, and this is actually pretty common for people using Parquet, for instance. Then we made a number of improvements to the core of the org decoder, and basically the inner loops of the decoding, when decoding values, got 2 to 7 times faster than before. Now that doesn't mean that your query is going to be 2 to 7 times faster. It means that if you have a query that is heavy on reads and it doesn't do much else, then you will see a large improvement. If you have a query that does a lot more processing inside Presto, you won't see as big of an improvement. If you look at, looking at the Tcpds benchmark, this is something that we tried out to see, like, what is the effect of this improvement on Tcpds, and end to end we saw an improvement of 10%. in CPU. This is actually pretty good. It doesn't necessarily reflect what you will see on your workloads, but it gives you a sense of how much you can see in practice. So there are a couple other performance improvements in various areas, like reducing the load on the metastore when accessing partition information, and when using spilling, there's the feature now performs better, it's more stable. So on the security front, one of the big features we added over the last year and a half is role-based access control. It feels like a long time ago, but this only happened in the last 15 months or so. There's another set of features we added. This is a kind of a capability that was added to the engine, but it was also extended to a bunch of different connectors. This is the ability for the credentials for there are some connectors where the user needs to get authenticated using the authentication system of the connector instead of authenticating directly against Presta. So with this feature, it allows the credentials to flow all the way from the client to the backend system and authenticate using, like, for example, let's say you have a Postgres database and you have a number of users and you want a user that is querying Postgres through Presta to authenticate using their credentials inside Postgres. This is what allows you to do that. So there are a number of other features. I'm not going to go into those. The one I wanted to mention, and we're going to talk a bit more about later, is we improved the security of the web UI, which was previously unauthorized and unauthenticated. Okay, I'm going to pause for questions here. Piotr, if you have any questions from the audience.
Nope, we don't have yet. I invite everyone to ask questions using the question box, and we'll answer them.
Right. Okay, moving on to the next. So, in addition to, I mean, another part of or another aspect of changes that happened, we have a bunch of new connectors in the distribution. Just to give you a sense of all the other connectors that we have already, like big laundry list of connectors. In the last year and a half, we added Elasticsearch, support for Elasticsearch, Kinesis from Amazon, and Phoenix. These were added sometime last year. There's also an experimental connector for Iceberg. They're still work in progress to make that connector more robust and make it production ready. And then over the last few months, we added the connector for MemSQL, Google Sheets, and Bigquery. Now, the interesting Google Sheets is interesting because it allows you to create sheets in Google, and then from a Presto query, you can access the rows and columns of the sheet as if they were tables. So this is very useful if you have some kind of dimension data that you're tracking and you want to be able to join against some other data set. You can do that in a single query now. Right, so Presto, this actually is something that was very surprising to us over the last year. So Presto is a pretty global phenomenon. Up until beginning of last year, we had no idea. I mean, and when I say we, I'm talking about Dane, David, and myself in particular. We had no idea how much adoption there was all over the world. Like we saw, I mean, we knew about all the people that interacted with the project directly, but we didn't realize there were so many people all over the world that were either using Presto, they were interested in Presto, and they were just not getting involved in the Slack channel or talking to us or any other contributors. So together with a number of companies, we ended up organizing summits all over the world. We did one in Tel Aviv in April last year. We did one in Tokyo. So the one in Tel Aviv with Varada and Wix, in Tokyo with Treasure Data, the one in Bangalore in India with Qubel, and then we also held one locally here in San Francisco with Twitter and Starburst, and then the one in New York also was organized by Starburst and Red Hat. So what was interesting is that in each of those summits we had, more than 150 to 200 people with representation from dozens of companies in each of them, and it shows how vibrant and how much adoption, how many people are actually using or interested in learning about Presto. So it was pretty eye-opening experience. We're going to share the slides later. These are all links to the different blog posts talking about each of the summits. So I encourage you to, if you want to look at the presentations, look at the slides for each of the presentations, you can just click through and see them. We also have a list of some of the most popular talks at each of those conferences. You can also look at them later. Okay, let's talk about some of the changes. These are changes that happened over the last few months in particular. So the previous list was changes from the beginning of 2019. These are a specific set of changes that happened over the last 2 or 3 months. So the first one is we added support for caching. This caching inside the Hive connector, and the idea is to be able to cache data from HDFS or S3 or one of the blob store implementations into local disk or local memory, and this can help. Local SSD. This can help with scenarios where the HDFS or the blob store is bottlenecked, or there's a network bottleneck talking to those systems. By caching things locally, those queries that access the same data set repeatedly can execute much faster. I mean, lower latency. It won't help with CPU necessarily, but it will help with latency. Then the next change that went in is support for ARM64. Presto can now run on ARM64 CPUs. This is important for cloud environments. Like, for example, in Amazon, they're starting to roll out, or they've been rolling out for a while, ARM-based machines. And there was an analysis done by Treasure Data where they can see a decrease in cost by running on that hardware. So now you can run Presto directly on that hardware. You might see improvements. You should try it out if you're using AWS, for instance. We added support for Azure, different versions of the Azure file system. This of course, improves compatibility with those cloud environments. I think there were also some improvements to the integration with GCS for Google Cloud Storage. So in general, this is a kind of a catch-all for a bunch of improvements related to integration with different cloud environments. Then another big change that happened over the last few months is we made a number of improvements to security, and the most notable one is we made the web UI secure. Previously, anyone that had access to the coordinator could talk to the Presto web UI, which, for example, could expose sensitive data because the text of all the queries was available. It also, the actions on the UI, like, for example, killing queries, was unprotected. So anyone that had access to a UI could go and kill a query. So now, when talking to the web UI, there's authorization in place. So only people that are authorized can access it. And there's authentication in place, and then authorization to be able to limit who can kill queries, who can see certain kinds of data from queries, and so on. And this has gone in over the last, I think it's 2 or 3 releases. Dane, correct me if I'm wrong, but that's pretty recent. There's been, so Dane is giving me a thumbs up there. There's been a number of, or a huge amount of work going in to be able to support the Hive asset tables. These are tables that allow for transactional semantics. So in the last few releases, we added support for being able to read from Hive asset tables This is including the base data, and all the deltas that get applied as the tables get modified. This only works on Hive 3 and higher, and I mean, if you're relying on that feature, you should be able to now query those tables. And then we added support for an experimental feature. The idea is when you define views inside Hive, those views today are not queryable by Presto because the syntax is different, the semantics are different. So we've added a feature where now you can start querying those views. That feature is behind a toggle that you have to configure because of potential semantic differences that you have to be aware of. But the idea is that now you can query some of the basic views that are compatible in terms of syntax, and we're doing a bunch of work to extend that to support more complicated queries. All right. So going onto the roadmap, and one thing I wanted to remind people is that Presto is a volunteer project. Everything happens when people volunteer their time, their effort. So the roadmap is usually defined. Oh, sorry. Let's pause for a moment there. I think there are a couple of questions from the audience. Piotr.
Yeah, sure. So you talk about the security, and there is a question from Tan G. Lee. Is there a way to disable the web UI security?
Dane, do you want to handle that one?
In the next release, because we're now doing authorization checks to see who can view which queries and who can kill queries, which are two of the important things the UI can do, the UI has to have a user. Otherwise, those authorization checks won't work. In the next version of Presto, we've added a new authentication type to the web UI called fixed, which allows you to say, everyone who's accessing the web UI will be automatically authenticated as a specified user. So typically you'll do something like create a user called web UI. And then you would grant that user the ability to see queries, see all the queries if you want anyone to be able to see all the queries. If you want people to be able to kill queries, you grant it the ability to kill queries. Assuming you have authorization installed. If you don't have authorization installed, then the default is anyone can see all the queries and anyone can kill a query. So in the next version, you will be effectively you'll be able to do something that accomplishes that.
And the next version is going to come out sometime later this week or next week. All right. Anything else, Piotr, or should we continue?
Please continue. We have questions, but we're not going to proceed later.
Okay. Okay, so I was saying that Presto is a project that is driven by volunteers. All the work happens when people contribute their time and their effort. So the roadmap is defined by what people are working on, what people have a passion for working on, or are going to work on in the near future. So we're going to go over some of the projects that are going on right now, or we know that are going to happen in the near future. We kind of categorize them in three buckets. On the performance side, we continue to make improvements to the ability to push down complex operations to connectors. The one that is coming up soon is support for aggregation pushdown. This is being done with collaboration with some of the developers at Netflix, and it should be coming in soon. It's under review. This is support. So this is support in the engine for doing pushdown. Then we'll have to integrate into different connectors. But in particular, it's going to be useful for connectors like Druid connector or Pinot connector that are going to be coming soon too. Then we made a number of improvements already to be able to push down nested field dereferences into Parquet and org. So for some kinds of queries that's already in place. So if you read nested data from one of those formats, performance will be much better. And one of the changes that's going in soon is better support in the rest of the engine. So this is when you have more complex queries, the engine will be able to infer that you're only trying to access a certain set of fields. And it will be able to push down all the way into the connector. So that will be available hopefully in the next 1 or 2 releases. We are also extending the dynamic filtering feature to not only prune data sets at the data source level, but also to be able to do partition pruning. So the idea here is that once the query starts running, and if the engine discovers from processing one side of the query that a certain set of values are potential candidates, it will prune the set of partitions that are being considered for the query while the query is running. And this can help short circuit very large queries that may be accessing, in theory, lots of partitions. And this will help with, in particular, with the high connector. We're also doing work to improve the Parquet Reader and Writer. If you look at, we talked about how we made the org reader 5 to 7 times faster in the inner loops of that code base. And if you compare the Parquet implementation with org, right now the Parquet implementation is about 5 times slower than org at that layer. So one of the things we're working on is a change, an improvement to make that faster and be on par with org. So right now, if you're looking for performance, the recommended format is org, but Parquet will get better soon. And then there's a project we've been talking about. There's interest from a number of people to help with. This is the ability to fetch data from Presto when a client is interacting with a Presto cluster, to be able to fetch data more efficiently. This implies improving the protocol to be able to parallel reads when the data can be parallelized by being able to talk to multiple workers for fetching that data. This can help with integrations with other systems like Spark, for example, if Spark wants to read from Presto as part of its processing. And part of the change is also improving the encoding formats. Right now, the format is JSON, and JSON can be inefficient for a bunch of different reasons. So we're looking into more efficient formats like Arrow or Message Pack. So on the connector front, there's a couple connectors that are going in. They've already been merged. They are going into the next release. These are the Pinot connector and Oracle connector. There are a few other connectors that are in the process of being reviewed: Influx, Prometheus, and Salesforce. And there are improvements for a number of other connectors, like support for the Kafka Confluent registry in the Kafka connector, and I'm getting the Iceberg connector production ready. And then finally, on the there's a kind of a catch-all bucket where we related to being able to be more flexible and supporting more expressive features in the language and in the system. There's a number of things we're doing. We're starting to work on the first steps to having materialized view support, and this is going to be this is a big and complicated topic. And we're going to start with the initial step of supporting the syntax and the ability to create those materialized views, with the ability to refresh them manually and have some ability to interact with them in a manual way. And then over time, we're going to make them more automated and improve the engine to be able to take advantage of materialized views for query optimization. The work that's going on right now is just adding the initial steps, which will be a pretty good feature people have been asking for a long time. We're also revamping the way the function registry and the way Presto deals with function registrations and resolution. Right now, functions are defined upfront when they have to be defined upfront before the Presto cluster starts up. They are hard-coded in the code, either in plugins or in the engine. So one of the things we're adding is the ability for connectors to resolve functions dynamically. And this is basically bringing the same treatment we do for tables, where in the middle of when Presta is planning a query, you can say, you can ask the connector, do you handle this table? What is the schema of this table? And so on. We're doing the same thing for functions. So at the point of query planning, the connector will be, at the point of analysis, it will ask the connector, can you handle this function? What is the shape of this function? And so on. And this will allow connectors to resolve the functions dynamically. Maybe they can provide implementation dynamically. Maybe they can look them up in a different system. Maybe they can synthesize them. So it adds flexibility to the system. Part of this change also is adding support for namespaces for functions. This allows connectors to provide functions that may conflict in their name with other connectors. And by adding namespaces, we allow the user to specify which connectors they want to resolve functions from first. This is similar to the concept of the path in Unix, for instance, where you say, I want to find my executables in the path in this order by looking at different directories. This is similar. I want to look for functions in different connectors in this specific order. Then after that, so once we have that capability in place, we have some prototypes of and work in progress to be able to support Sql Defined Functions. And these are functions that are defined using a Sql dialect. It's kind of very similar to BASIC. It's a procedural dialect using SQL semantics. So the idea is for people to be able to define those functions dynamically by using SQL commands and syntax. And then after that, one of the things we're going to start looking into is support for polymorphic table functions, which are a feature in the SQL 2016 language that extends and enhances the expressiveness of the language in a pretty dramatic way. We mentioned how we can support basic high views today. We're going to be working on extending that to more complex views by using a translation layer between Hive syntax and Presta syntax that will be semantically, will do the proper semantic transformations. So this will be able to handle more complicated queries with the knowledge that the semantics are going to be the same across both engines. And then this has been a feature that has a bunch of people have been asking for a long time. So traditionally, Presto has supported fixed precision datetime types, in particular, for example, for timestamps, timestamp with time zones, intervals. The precision is milliseconds, and this oftentimes is not sufficient. For example, in the financial industry, where they deal with events that have significant more granularity, for example, at the nanosecond level, this is not sufficient. So we're making changes to the engine to support variable precision for those types, and it should be able to represent, for example, a timestamp with nanosecond precision without problem. And then finally, we're continuing to improve the support for Hive 3. There's still some rough edges in terms of compatibility that those will be fixed over the next few months. Okay, so with that, we'll open up to questions.
Thank you, Martin. So the first question would be is from Rohini Palaswani about the plans for Druid connector. David, maybe you would like to answer that.
So I believe someone in the community is working on a Druid connector, but I don't know anything off the top of my head. I think it's actually Netflix working on it.
Yeah, I can take that one. So there's a pull request open for a Druid connector that's under review right now. It's probably going to be merged. We're going to finalize the review over the next few weeks and get it merged. There's been discussions among different community members of potential improvements we can make. So once the connector is merged, we'll do those improvements later. And this is the basic connector. One of the things that's going to happen is as soon as the aggregation pushdown is is added to the engine, support for aggregation pushdown is added to the engine, will integrate with the connector, which is going to be one of the first ones that will be able to benefit from that feature.
Thanks. A question from Gautam Manchikatia about any idea on when the acid write support will be available. Dane, would you like to answer that?
I was thinking you'd be more qualified to answer that, Piotr.
Yeah, maybe I can try to answer that myself. So this is definitely on the project's roadmap, but that's not like there is not a fixed timeline for that effort. That may be something that Starburst will happen to be working on this year, but I can't promise that.
One other thing, and we as the community have been exploring not only extending so Presta already supports row level delete. It's used in the Raptor connector, but extending that to the Hive connector specifically for Oric Acid. But we're also starting to discuss like how updates or merge and some of the more advanced commands to mutate data will be implemented in Presto. So we have some ideas, but it's in the very early stages for the more advanced updates commands.
Thanks, Dane. And speaking about Raptor, there is a question from Eugene. Is there a new Raptor connector in the roadmap? David, I think you will be the best person to answer that.
It's still on the long-term roadmap, just needs to be a priority to work on. So I would like to get it done, but I've got a lot of things to do, so no promises on a specific timeline.
Thanks. A question from Roman Zaide about, could you please elaborate on the aggregation pushdown effort? I think you described, Martin, this in a bit, but maybe you can share more detail about that.
Yeah, so the idea is, so we have a kind of a model for how the engine pushes down operations into the connectors. And the idea is to, connectors can implement certain operations, like they can say, for example, I know how to handle a projection, or I know how to handle a filter, or I know how to handle aggregations. The engine will, during the optimization process, call the right methods, call each of those methods and say, whenever the shape of the query warrants it, and you can say, the connector can say, yeah, I can handle this. And the engine will rewrite that part of the query with a new, more appropriate operation. For aggregation pushdown, we're following the same model. The idea is if you have a table scan with an aggregation operation on top, the engine will recognize that pattern. They will say, we'll ask the connector, do you know how to handle this type of aggregation on top of this table? And the connector can say, yes, I do. And here's a new rewritten table that you have to read instead. There's a couple of limitations here. One is it only handles full, non-partial aggregation. For example, if you're saying you're doing a count or a sum, it can either push the entire sum or it can't. It can't split in half, and it doesn't do. If you have a partial sum, for example, if you have your plan is already split into a partial sum or a partial final sum, you won't be able to push the partial sum because that requires being able to define what the intermediate results out of aggregations look like, which is up until now an implementation detail of the engine. We have no protocol for describing that and expressing that between the engine and connectors. That would be an extension to the work that is going to happen later. We wanted to get the initial ability to do full aggregation pushdown before anything else. And this would be sufficient for connectors like Druid or Pinot, which already do full computation of aggregations anyway.
Thanks, Martin. Still about the pushdown, there is a question about pushing down whole queries to JDBC connectors, and specifically whether it's on the roadmap for the year, for this year.
Right. So the idea is, so we have to understand. So when a user submits a query, the connectors don't see the query itself. What they see, what the engine does is it turns a query into a query plan, and then the engine can communicate to the connector that certain parts of the query plan are of interest, and the connector can decide whether it understands them and it can push them down into the data source. So the notion of you're going to be able to take an entire query and push it down to a connector, that will probably never, it will never be done that way, because the semantics of SQL and Presta are different than the semantics of what connectors provide. So we have to go through this intermediate translation layer that is the plan, the query plan. In terms of extending support for whatever the engine can push down today into connectors to the JDBC connectors, we already have support for limits. We support filters. As we continue to expand support for more complex filters, we'll add the integration into those connectors. For aggregation pushdown, as soon as the feature goes in, we're going to have to add it for the JDBC connectors, in particular because the Druid connector is based on JDBC right now. So as we continue to expand the ability for the engine to push things down into connectors, we'll extend the JDBC connectors to that to support those features.
I just want to jump in and say, so a different way of thinking about the answer to that question is, can we push down whole queries into the JDBC connector? The answer is, of course, we could do that today for limited sets of queries. If your query is select star from table limit 100, that entire query gets pushed down. What Martin's talking about is there's limitations on what can be pushed down. So at some point, your query becomes complex enough that parts of it are no longer pushed down, and so only parts of it are executed in the external database, and parts of it are executed in Presto. And our goal is to get better and better at this, so that when possible, when there are equivalent semantics in the target system, we can push all those down. But there will, of course, always be queries that don't push down. Like, for example, there's no other database that I know of that supports the Presto Lambda syntax, for example.
And another thing you can do today is, if you create a view in the target database, when you query that view is completely executed in that JDBC database. So, and that view can be arbitrarily complex, whatever that underlying system supports.
Thanks. A question not about a pushdown. So a question from Ashar Hassan. Whether there are plans for using data locality when using, like, to leverage data locality when using caching.
I can answer some of that. Yeah. So Presto already leverages data locality. If the connector provides information to the engine about where the data is located, the engine will, based on there's some configuration options, but based on some algorithms you can switch between, it'll choose where to place work such that it's closer to the data. Today, the Hive connector and the Raptor connectors are the biggest users, or the biggest suppliers of locality data. When we're specifically talking about the new Presto native caching, the native cache provides locality information to Presto, and Presto is very good at placing work such that it should be machine local where possible. But sometimes you have skewed workloads, and Presto will also spread it out and adapt, so you don't end up like queued behind one worker that has very popular data. So this is something that's in already today.
Thanks, Dane. A question from Chip Maurer, who would like to extend Presto. David, is there a cookbook document for writing new connectors? How do you write a connector?
So the best place to start is to look at the source code for an existing connector that is close to what you want to do. And if you're not sure what that is, or I mean, actually, the first thing you should do is join the dev channel on Slack, and you should like ask for help. And someone there can like find out more about what you're trying to do and point you in the right direction. We have a lot of connectors that cover very different use cases, and there's likely one that is pretty close to what you're trying to do. And so we don't really have like great documentation around like all the things to write a connector, because writing a connector, there's so many different aspects to it. It'd be really hard to document that. So the best thing to do is ask for help, and we can point you out code that is hopefully close to what you want.
Thanks. And still on the extending, Ashfar Hassan would like to know whether we will provide out-of-the-box implementation for different authentication systems, and for example, Keycloak, which is OAuth-based. Dane, would you comment on that?
Today we have out-of-the-box support for a number of authentication schemes, from simple username and password using LDAP or files to Kerberos for much more complex environments. So the answer is, as time goes on, we add more as people start to as there's demand for things, as people offer them. I'm not familiar with that one in particular. But I don't know of any current plans to add any more right now. I haven't seen any chat on the security channel or anything like that.
Thanks. Martin, there is a question about the planner. Will Presto ever support SQL hints like other databases do, for example, Oracle, that could help with optimizing the query plan?
We talked about that on and off over the years. I think at some point we will. It's just a matter of figuring out what the semantics of those hints are. How do we want to express them in the syntax? One of the challenges is that we want to avoid is those hints becoming requirements. Like, for example, if you say, "Oh, this should run in this way," what happens when the engine does no longer support that, or it can do a better decision? Is it a hint or is it a command? And so there's a lot of nuances that we need to figure out before we can add something like that. But it's on the table, yes, as a potential thing.
I will add to that a good parallel for this would be the story about a different project where they had hint support, and they had improved the optimizer, and they added configuration toggle, honor hints, ignore sprints, and hints to ignore the configuration toggles that say ignore hints, and so on. So it's a tough thing. A question from Karthik Kondamundi about currently whether when there is a node failure, the entire query fails, and so the question is whether there is plan to introduce query resilience for those types of failures. Dane, would you like to answer that, maybe?
Sure. So this is a thing that comes up from time to time. So we've talked about adding support for like some form of checkpointing inside of Presto. And the reason this hasn't been implemented is because it's actually not typically a real problem. So workers dying is almost always a problem of misconfiguration of the workers. And typically, when people have this problem, they show up and they ask, hey, are you guys going to implement this? And we say, hey, here's a couple of config changes you should make. And then the person never comes back because like their system works fine. So the problem is that it's a lot of work. And in most cases, like workers aren't dying. And then even if we had this, you would still want to configure your system so workers don't die, because that's a fairly expensive recovery technique to be able to like go back and restart whole sections of queries. So I could say we've talked about it, but it's not something that is high on the priority list for anyone that I know of.
So another reason people ask about this is that they're trying to run on like spot instances or whatever the equivalent is in a cloud, where like the instances can go away at any time. And another technique we've talked about for those is, so spot instances like don't just go away immediately. You get a short notification that it's about to go away. So we've talked about adding a system where work can be moved off of those nodes onto different nodes. So it wouldn't be like fault tolerant where the node just crashes and you recover, but you would be able to like prevent the query failure by moving the work. But actually implementing this is a large project and we haven't had time to tackle it.
Thanks, David. We are over time, but we have some more questions, so we can stay. I encourage everyone to stay. A question from Shiv Gowda about whether we plan to support to have long-term stable releases. Yep. Martin, maybe you would like to answer that.
I mean, from the point of view of the open source project, we don't have any plans for that. I mean, there's a complexity associated with maintaining releases for a long time, and I mean, it requires people to be able to. I mean, it requires people to basically volunteer to be maintaining those. So we don't have expectations of being able to do that. I would say for that kind of support for long-term releases, you might want to rely on commercial vendors. Like, for example, Starburst has a plan for that, and I believe other vendors may do the same thing.
Thanks, Martin. Just for clarity, Starburst long-term supported releases are free for everyone, so it's not really a commercial thing, so to say. David, could you please elaborate where we can expect optimized Parquet Writer? This is a question from Sandesh.
So there was an optimized Parquet Writer merged into the code base, I think a few months ago, but it's still yet to be fully integrated into the Hive connector. But I would actually expect that we'll probably do it first for Iceberg, because Iceberg is like new and still experimental, and there's other benefits for having more control over the Parquet stuff for Iceberg.
There's a PR to integrate it into Hive that I'm reviewing, or maybe I finished reviewing it. I don't know, in the last like week or so.
Thanks. Also, just to be clear, the optimized Parquet Reader is something that we have for a long time already. Another question, Martin, you mentioned support for materialized views. How do they relate to materialized views in Hive?
I'm actually not familiar with materialized views in Hive. Maybe David can talk about this one if he knows.
I'm not familiar either.
Mm-hmm.
Thanks. So also on the Hive views topic, you mentioned on one of the slides you mentioned the support for Hive views. So the question how they will be handled. I guess it's not about materialized views.
Yeah, so the idea with, I mean, a Hive view is effectively the text of the query using Hive query language. So when Presto says, I want to query that view, the connector returns today. The only thing it can do is return something that is the result of processing that query and trying to turn it into something that is compatible with Presto. And in the current version, there's some simple transformation like to deal with some syntactic issues. Where one of the things we're going to improve is there's a project from LinkedIn that they just open source to be able to translate from Hive queries to Presto queries and Spark and so on. So we're going to be leveraging that to do translation of the Hive syntax into Presto syntax, and while maintaining the semantics of the query. So that's the idea. The connector will, before handing off the definition of the view to the engine, it will translate it into something that Presto can understand.
Thanks. And the project, I think you didn't mention the name. This is the Coral project.
Right.
Okay. I think we answered all the questions, but fortunately there will be soon a next webinar with Henning Schmidhausen presenting, and there will be also a Q&A session then. So I invite you to that webinar, and this is on June 30. Also feel invited to join our Slack channel, Slack group. There is where most of the community interaction happens these days. So a lot of good content, a good place to ask questions in general, get help with Presto, whether this is about development, about running Presto, about like I'm just new to the project, how do I start questions, all sorts of questions. So see you there.
Thanks, everyone.